Hi, everybody. My name is Vishal Lala. I'm the Managing Director of Polar Racking. Welcome to our webinar today about selecting resilient racking for the Caribbean. Today, we're going to talk about our company. We're going to talk about the services that we offer and foundation design, and about a couple of projects that we have. Couple of projects out of the many projects that we've worked on in the Caribbean. Today I will be a speaker here, as well as Arash Yazdani from PRI Engineering and AJ Kiani, who is our sales manager for Canada and the Caribbean. Before we start to talk about Polar, I'll turn it over to Arash so we can talk a little bit about PRI, and then we can jump into it. Just as a heads up to everyone, we have a couple of polls that are going to be coming up, actually 3 poll questions that are coming up. We're hopefully you guys can interactively participate, and it'll allow us to learn a little bit more about your business, and it'll help us when we get back to you on how we can best serve you. So we've never done these polls before in the webinar, so we're really excited to see how the feedback and the interaction is. So with that, I'll turn it over to Arash. If you can introduce yourself a little bit and tell us a little bit about PRI, I think that would be a great start.
Yeah, no, thank you very much, Vishal. Appreciate the introduction. My name is Arash Yazdani. I'm the Director of Engineering for PRI Engineering.
We do have a focus on pile design and geotechnical engineering for solar facilities. So we do that, and one of our main focuses has been taking developers, racking companies, other players in the solar industry through the design process of the foundation. We've got a team of over 10. There's 4 PEngs, licensed engineers. We've got technicians, technologists, and a whole supporting team to oversee all your projects. And our ultimate goal is to save you money, but not take too much risk, or not allow you to take on additional unnecessary risk by doing so.
Appreciate that introduction, Arash. And as we get through the presentation, we'll actually have a few slides dedicated to foundation design. And again, just speaking to some of the experience of the combined team between Polar and PRI and working on foundations, and the benefits of really having a strong foundation design, not only for the lifetime of your project, but through constructability as well. So with that, I'll introduce you guys, tell you a little bit more about Polar Racking. So Polar Racking was founded in 2009. This is our 12th year in business. We're primarily solar panel mounting systems manufacturer. So we initially started as rooftop, and since have moved into ground mount, carport. We make our own foundations, ground screws and helical piles. We supply driven piles. And many ballasted foundation options as well, such as pour in place, precast ballast, geoballast for all your projects. We are a Canadian leader in this space, and we have been supplying projects in the Caribbean and in the US for at least the last 10 years. We have over 360 megawatts installed to date, with actually a pretty aggressive pipeline of projects coming up. So here's a quick look at our product portfolio. So once again, we started as rooftop, and we still do quite a bit of flat rooftop systems all over North America, including the Caribbean. Our flat rooftop solution is called a PRG. It's a grid-based ballasted solution, which means that the grid is completely interconnected, and generally you only need ballast in the perimeter of the array. So extremely lightweight, self-spacing components, very, very easy to build. And not much thinking on the roof once you get there with the PRG. PRR is our flush mount solution. We have traditionally done a lot more commercial flush mount rooftops than we have residential. However, the product works well for both. And we have a lot of PRR installed in the Caribbean as well, particularly in Barbados, but as well as Dominican Republic and Bahamas. We've done a lot of our flush mount, very, very nice flush mount projects in that area. PRUD is our small ground mount solution. So generally projects under 500 kilowatts, we have a kind of a standard out of the box design. It's an over designed solution that can work pretty much anywhere in North America. And it's generally found through some of our distributors, and you can get the distributors' contacts through our website. PRU, which is the topic of our presentation today, is our fixed ground mount solution, and again, we'll go through that in greater detail. We do make our own helical piles, we make our own ground screws, we supply driven piles, and I said we supply solutions for ballasted options, whether that be a pour-in-place tub or a geoballast basket. We can work with you, based on your project and supply everything basically from under the ground all the way up to the complete racking solution. And our latest product that we're actually having a lot of success with these days and happy to see is our PRP product, which is our solar carports. So we're very active in this market as of the last 2 years, and we're really gaining a lot of steam here in North America, obviously in Canada and the US, supplying many projects from California all the way to New Jersey. And we are suddenly quoting quite a few carports in the Caribbean. We've yet to supply our first one, but we're anxious, we feel very confident that will happen this year. So again, what is polar racking? Polar racking, we offer engineering services. We do offer installation services. We don't have our own crew of installers ourselves. We generally work with local installers. We supply construction management, project management for sites. And we also, and that's all basically built on a platform of high quality, simple to assemble products. So again, this leads us to our first poll question of the day, which is, what are your main challenges in solar project design and construction? So again, these poll questions are intended for us to learn a little bit more about you, the people attending the webinar, and hopefully it'll help us, refine our offering to you next time, and ultimately service our customers to a higher level. So take a quick second to answer that. There's 3 of these poll questions that will be coming up throughout the presentation. So I assume you've had a chance to pick from your multiple choice now, and we'll move to the next slide. So PRU, so again, we're here today to talk about PRU, which is our fixed ground mount racking solution. It's used for large scale ground mount solar projects, pretty much starting at 500 kilowatts, but can be used for a 500 megawatt site as well. What's different about PRU and the polar racking solution, and why does it apply well for the Caribbean? Our solution, being a Canadian company, is built for heavy loads, heavy wind, heavy snow, heavy ice. So compared to what you're going to see from a lot of our competitors in North America, especially, this is a robust, very robust structure that, it's very easy to see. If you're driving around, especially Barbados, where we have a lot of systems, and then there's competitor systems, you'll be very easily be able to identify which one is a polar racking system, because again, we pride ourselves on building very robust systems that are built to last. There's other, systems out there that, they're built for the developer to build and flip and whatever. This is built for someone that wants to own a system long-term and doesn't want to worry about the system, no matter what the loads are. So what do we pride ourselves on with our polar racking solution? Definitely greater adjustability. We use heavier gauge is north-south beams and east-west beams with fewer braces to, to secure everything together. And with that, we're able to provide or offer a much wider range of tolerances in all directions. And we'll get to a slide that'll show you or give you a visual of what that looks like for you practically in the field. We offer multiple clamping options for your modules, so we can do top-down mid clamps, or we can do direct bolt connections, and we've done both in the Caribbean. We have built-in wire management. Again, we'll show you a little bit more about that, and UL certified integrated bonding. Our product is highly customizable to match your layout. So if you're telling us you have strings of 18, of 25, of 13, whatever it is, we will we offer a table design, so rather than a continuous row design. So we're able to customize our table design to match your string or to match the layout, as required. On our landscape version, you can pre-populate modules as well onto your table. And I think most importantly, out of all the options we offer, is that we let the ground tell us what your foundation type should be. So where there are some players out there that are the ground screw guys or the helical guys, we know that to build a project that's built to last, you need to do the best thing to attach to your given ground conditions. So again, we've worked with driven post, helical piles, ground screws, ballasted solutions. So we offer you the options, so you're not pinned into choosing from, the best of the worst that's available. Like we want to put the best of the best that's going to make your project last, for really until you decide to take it out of the ground. So what are some things that we consider when we're looking at a foundation, or not a foundation, but a racking design overall, but especially in the Caribbean, because the Caribbean has very unique characteristics when you're dealing with steel and when you're dealing with structures that you have to pay particular attention to. So those things, obviously, when you're coming to us and you're giving us information about a project, or what we're going to be asking you when we're looking at a project is, what is the wind speed that we're looking at? Different islands have different wind speed, characteristics, and we've worked on many islands, so we're able to accommodate that. What does corrosion look like? How close are we into a corrosive environment? What are the ground conditions again? And we'll talk more about that. What's the topology of your site, and how can we help mitigate your civil costs in terms of preparing the site by playing with our racking design, or adjusting our racking design and adjusting our foundation design to help manage those costs. What's your availability of equipment on the island? Do you have machines to be able to drive piles, or do you have machines to be able to turn screws, or is there a lot of concrete there, and is the concrete expensive or is it inexpensive? And how can we take all those factors to provide you with a design that not only works, but is very buildable for you on site? And then what are the requirements from the module you're using? Now, the tricky thing that we're finding in the Caribbean is that we can design our rack to withstand the loads, but a lot of times the module manufacturers are the ones that have special requirements for clamping that we're not finding in North America there, or in mainland, if you want to call it Canada or the US. So something we're keenly aware of, and we work with you along with your module manufacturer to come up with a solution that will not only last, but that will make the module manufacturer happy, and ensure you to get your full warranty out of the module guys. So what are some of the tricks what are some of the aspects of the designs that we use and adjust when we're working on these types of projects? So again, we've mentioned it, heavier gauge beams and braces. Like, we pride ourselves on having a very robust design with not so much bracing and things that others do, and we feel like that makes for you know, obviously when there's less assembly, there's less points of failure that you can have. Makes it easier to put it together in general, and it makes it easier to maintain, you know, over the lifetime of your project. And we feel that that's a very, very important thing to consider, you know, when you're building in these areas with heavy loads. Thicker galvanization, I mentioned corrosive environments. You know, we can offer up to G2, you know, from G90 to G235. So if we're talking about a project in New York, we're generally going G90. But, you know, if we're talking about a project in the Caribbean, we're generally, you know, G210 or higher. One thing that polar racking does do that again, you know, sets us apart is we offer stainless steel fasteners on all the connections. So some others might give you stainless steel connections for the for just the module connection, but you know, we feel that on these islands, stainless steel for all the connections is definitely the way to go. Again, we do offer highly adjustable connections to the foundation to accommodate topology. Ultimately, we know that civil costs are huge when it comes to building a solar project, and in order to mitigate that cost or reduce that cost as much as we can, we've made our connections very, very adjustable so that you know, you're able to limit that cost. And then lastly, you know, again, like I mentioned before, we offer a mid clamp and a direct bolt bonding options to your module, and something that, you know, you have to be very keenly aware of, especially if you haven't built a project in some of these high wind zones, is, you know, what is the requirement from your module, you know, your selected module supplier, because you know, it won't be necessarily the same as what you're used to if you're used to building projects in Canada and the US. So we offer two table designs for our projects in the Caribbean. One is a standard for east-west beam design, and generally we can offer this up to 150 miles per hour. Again, we do a lot of testing internally, a lot of you know, simulation testing as well, and a lot of testing with third parties to make sure that, you know, our connections are strong and robust and can withstand the given load. So the other design that we have for Caribbean projects greater than 150 miles per hour is a 6 east-west beam design. So again, this goes mostly when you have higher loads and you have a module manufacturer requirements for certain clamping, whether it be, you know, 6 spots or 4 spots, direct bolt versus mid clamp. So, you know, this is to show that we do have the options. They're ready, they've been deployed, and we feel very comfortable with these, you know, solutions that we're offering out. You know, again, because we are accustomed to dealing with heavy loads, you know, very comfortable working with these more robust designs and coming up with these options for you than some of the other players in the market these days. So, you know, I neglected to mention at the beginning, but you should be writing as many questions as you can in the chat. And after we're done with this initial part of the presentation, we are going to open it up to questions, and we will be addressing all the questions in the chat. So I see the number popping up there, and I'm happy people are asking. So we'll definitely address that as you know, at the end of the presentation. This slide particularly that I wanted to draw your attention to shows you the adjustability that we have in our product that you often won't find in other products. So especially on a driven post design, which we're finding more and more common, and we're able to achieve more, and even a grouted post design, as opposed to some, you know, as opposed to I-beams, you know, or W sections or H-piles, you know, whatever you want to call them, because everyone calls them by a different name. We prefer to use a round post design. We feel the round post design gives us, you know, greater structural integrity because, you know, it's strong from all given directions. And then secondly, it allows you a lot of adjustability in the field. So, you know, your up down, we show 2 inches here. Really, you know, practically you can have 4 or 5 inches depending, you know, on your orientation. So I have our construction manager here telling me up to 10 inches. So you know, you have a lot of play when you go with the round post design, and you know, have a more structurally sound product as well. And then, you know, again, in all connections, we've added as much adjustability as we can, and this really helps with, you know, assembly, especially when you're dealing with different topologies, but also when you're dealing with tough ground conditions, because, you know, the piles don't always go in dead on straight, and you want to have something or a product that has play for you to be able to adjust in field, rather than pulling out the pile, recompacting the soil, and then putting the pile back in the ground. And what our design does is allows you to really pick up on, you know, if, again, we go with the discrete table design for the same reason, as is that, you know, within a table, if you have a pile that's, you know, 6 inches off, like, you'll be able to make it up just within the tolerance of the rack without having to take out the pile and do all kinds of extra adjustments. So we've seen it practically in the field, and we've heard about it a lot from our installers, that it's, you know, this is huge when you know, the rubber hits the road, and you're building and you're under time constraints, and you need to get the job done right. So and then this is, you know, another slide just show the adjustability on our dual post design. Similarly, lots of up and down tolerances, lots of tolerances east, west, and north, south, to accommodate, again, the different changes in topology, as well as, you know, having some of the posts go in the ground, you know, slightly off tolerance, so, or off their mark. One of the main features of the PRU system that we take a lot of pride in is our wire management. Our channels are built in with, you know, are built for you to run your cables. There's drainage holes in all the east-west beams so that water doesn't accumulate within the beams, and there's pre-punch holes so you can tie the wires up. So when you're on a polar system, generally you have a very clean looking system from you know, the front and the back, and you don't have to, you know, spend money on additional you know, wire trays or anything like that. So it's a very clean product. We do have ETL certification as per UL 2703 for Canada and the US. We have wind tunnel study from CPP. We have a lot of third-party mechanical design testing that we're happy to share with you, or a third-party IE in case you have a financing company involved in your projects. And again, a lot of finite element analysis testing and internal load testing data that we're happy to share. Now, you know, going back to foundations, we do offer many foundation options. So on a single post, you can do a driven post, you can do a graded pile or a helical pile. On dual posts, you can do ground screws, helical piles, or ballasted solutions, whether it be pour in place, precast, or geoballast. And the geoballast it's basically, you know, a basket where you can use, if you have a lot of rock, you know, at site, you know, oftentimes that's where we've seen it being used, or most times we've seen it being used in those situations where you have a lot of rock on site. You're able to take advantage of that and create a geoballast basket if that works for you. So here we are on the second poll question of the day. I feel like this is an interesting thing, asking the poll questions like we're in a game show here. But yeah, happy to. Oh wow! So and you know, I'm seeing the results right away. So lots of people looking to build projects this year. So that's, you know, that's very exciting, and that's what we want to see. And you know, hopefully we can talk to you guys about that. So. Very nice. With that, at this point of the presentation, I'll turn it over to Arash at PRI Engineering so he can talk a little bit more about foundation design, the services offered, and the advantages of conducting a proper, you know, geotechnical investigation prior to commencing your project, and the advantages of that. So.
Okay, thank you, Vishal. My apologies. I don't think everyone was able to hear me that well in my introduction, so apologies on that. I think everybody can hear me now. Yeah, so just in case you miss it, I'm Arash Danny of PRI Engineering. I'm a geotechnical engineer and have worked on, me and my team have worked on over 2 gigawatts of foundation design for solar structures all across North America, including the Caribbean. And, you know, as a geotechnical engineer, we obviously, we deal with the ground, we deal with the subsurface conditions, what you can't see, what a lot of people call the black box of civil engineering. And, you know, some people may wonder, well, what's a geotechnical engineer from Canada doing in the Caribbean? And, you know, that's, I'm happy Vishal brought it up. You know, it really shouldn't matter on what the ground conditions are. The key is letting the geological conditions of the site drive your foundation design. Too often we see certain racking manufacturers say, oh, this will work, you know, we always use this, we always use this. And I just find that that's the wrong way to start a project. If you've pigeonholed yourself into a certain type of foundation, you know, it's almost like trying to put the square peg in the round hole. You know, you're forcing it, and anytime you're forcing foundations, you know, you could have issues arise. So, you know, one of the main contributing factors for foundation design needs to be the geological conditions, and a lot of times that means a very rigorous subsurface investigation program. On top of the geological conditions, other thing that needs to be considered is also the racking system loads and of course the tolerances. So Vishal mentioned the tolerances, and you know, one of the big challenges with foundations is often they're very sensitive to potential obstructions in the underground, and obstructions can throw your foundation final location out of plumb, or, you know, ultimately out of position, to the point where you may need to do modifications to your racking system. You may need to look at removing that foundation element and replacing it, which, you know, is going to be costly for the removal. And then once you get into customizing racking systems, that could, you know, void your warranty or cause other issues down the road. The other thing that needs to also be considered during foundation design is load application and frequency. So what I mean by that is wind uplift acts very different than frost uplift. Snow load obviously not being a thing here, but, you know, that works, that acts differently than wind compression load. So you always need to think about what is the interaction between your natural environment, the wind, the ground, and your racking system, and what type of frequency is actually being applied to the structure. And we'll talk about how that we'll talk a little bit more about that in a couple slides about pre-production. I do see a question here, and I think it is probably very timely to answer. The question is, how is wind and frost different? That's a really good question. So anybody that maybe is familiar with wind, typically you might be familiar with the concept of gust wind, or, you know, a 3-second wind, an average 3-second wind. So wind acts on a structure and then it calms down. It's not what you call a long-term sustained load, whereas frost will act over a long duration. And in fact, it's going to grow with time as the frost in the ground, as the frost penetration in the ground expands, it gets deeper. You have more days under zero. The frost is expanding, and it's going to cause further expansion to the foundation, and that's going to apply a load over months typically. If you're in a northern environment, that, you know, the 4 or 5 months of the year it's below freezing. With respect to wind, like I said, it's slow acting. So it's typically 3 seconds is kind of what most of the codes suggest to use. But, you know, the fact of the matter is it's not going to be a long-term load like frost is. And so that's the difference. You know, to sustain a load that's turbulent, on, off, you need to have you need to be able to resist the load differently than if that load is slowly acting and slowly but surely pushing the foundation element out of the ground. So it is something that needs to be considered in the design phase. And like I said, we'll talk about that a little bit more during in 2 slides. Could I get the slide changed? Thank you. Okay, so now we wanted to talk about some of the common foundation types for solar racking systems in the Caribbean. So there, these 3 soil types that I've listed are going to probably cover 95% of the cases that you would come across in your sites. And so just to kind of go over them quickly, so a soft bedrock. Many of you that have been down to the Caribbean for a vacation and got on the beach and maybe went for a little snorkel, got to see the nice coral reefs. Coral reef is a limestone sedimentary deposit. So it's very similar actually to a lot of the limestone sedimentary deposits we see in both the northern United States and in Canada. The difference between the rock here and there in those depositions is that it's a lot softer in the Caribbean. So because of that, you can actually drive a pile through it. Now, there is some tests, there is some tests that can be done, but in all honesty, nothing beats doing the actual physical test yourself on the site ahead of time in the form of some sort of pre-production testing, which we're going to talk about a little bit more on the next slide. So that is a really good foundation type that we're not seeing a lot of people use, but it's definitely something that needs to be considered. Is if the bedrock is soft enough that it can be penetrated, driven piles should be one of the first options that you're looking at. If that doesn't go successfully, another option is ground screws. One of the challenges with ground screws is you do need to do a pre-drill. So what that means is that, if you picture you're trying to put a ground screw, which anybody that hasn't seen a ground screw, just picture a big wood screw that you use on your deck going into the ground. So, that may not be able to penetrate that soft bedrock. At times it might, depending on how soft it is, but it's probably best to assume that you're going to have to pre-drill. So that's an added step, hence why the driven pile is more attractive. You go to the pile, you drive it in the ground, you walk away, you're ready to rack. Ground screws, typically you'll need 2 crews, 2 pieces of equipment. You would have 1 crew ahead pre-drilling the holes, and then behind that, you would be putting the ground screw in behind it, and then you'd be ready for racking. But once again, you're adding a step, which is going to add a cost. Sometimes the bedrock might be too soft, and the ground screw might not be able to develop the adequate resistance because of the disturbing caused by pre-drilling. In which case, then you're probably looking at a bedrock micropile as the option. So, Michelle did mention that that's kind of what's most commonly been used. I can tell you that we worked on a project with Polar on this, and we were able to help save the project almost $1 million because the original proposition on the table was option 3 there, bedrock micropile, and we were able to prove that a driven pile would be successful at that site. So major cost savings. We're not talking about just a couple bucks here and there. We're talking major amounts of money that could be saved. And as I said during my introduction, our goal is ultimately to help you make the right foundation decision without taking on any additional risk. If using a driven pile means that there's more likelihood of that foundation failing, we as the engineering team haven't really been successful in helping you on your project because we've just led you down a road of additional risk. So soft bedrock, as I mentioned, one of the big key things about it is it's penetrable. When we talk about hard bedrock, that's more of a igneous formation, volcanic in origin. So this is very, very hard. granite, so very similar to the material that you'd have for your countertops. Hard material that you could pound a post on it all day and you wouldn't go anywhere. So bedrock micropiles or ground screws, I'd almost say 1A, 1B in terms of what is the best option. Bedrock micropiles, we didn't talk about it in the soft bedrock section, but what it essentially is you drill a hole, you set your pile, and then you grout it. So the added cost there is concrete. And for anybody that has experience working in the Caribbean knows that concrete and cementitious materials is not readily available. Most of that material needs to come, like anything on the islands, on a boat. So you're looking at additional cost to bring in that material. And cement is a time-sensitive material, and what that means is when you mix cement to make concrete and you add water to it, you have a finite amount of time where you can actually use that. So that it really makes construction planning more risky and more challenging. So if you can eliminate concrete from the design, you're ultimately making your construction a little simpler. With regards to the ground screws, they are a possibility. One of the challenges with the ground screws, and to go back to the soft bedrock, is those threads on the ground screw actually can bite into the bedrock. The rock is soft enough that it can engage into the rock, and you're gaining your resistance because those threads are locking into the bedrock. That's not the case with a hard bedrock. It will basically file away those threads. So what you're needing to do in a lot of those cases is you need to pre-drill a hole that's larger than your threads. You'll have to put some sort of sand or screening material in the hole and then drive the ground screw into that after the fact. And once again, if you don't get torque, you're likely looking at resoluting that with grout. If you're not getting your adequate torque to get your adequate resistance, like I said, you're gonna have to grout that concrete. We've already talked about the challenges with cement materials, and that's gonna cause the cost to escalate in your construction. The next type of soil, most common soil, is a deep soil overburn. So that just means that there's likely bedrock somewhere down maybe 10, 15, 20 feet, but it's deep enough that it doesn't make sense that you're going to found on the bedrock. So you need to depend on the overburdened soils to provide your resistance. So similarly to the soft bedrock, one of the most usable solutions is a driven pile, definitely the most cost effective, primarily because it's one process. Same with the ground screws. Into a soil overburden, you may not have as many issues related to pre-drilling, but if you do come across large boulders, cobbles, there could be some obstructions in the way of the ground screws, which will then require you to pre-drill. So, it's possible in a soil environment, the ground screw could go in on the first attempt, but there's also the risk that it doesn't, in which case, you're back to the same challenge you are with soft bedrock, in which case you have to pre-drill. Soil micropile, a lot of the same challenges as with the bedrock micropile. We talked about the concrete and cementitious material challenges. Another issue that comes with soil micropiles is, related to hole stability. If you've got a wet site or a shallow groundwater table or something of that nature, it's possible that the soils in that boring will not stay stable, meaning that, when you advance your auger or down the hole hammer to make your hole, when you remove it, everything just collapses in. And everything collapses in, obviously, we're talking about another added step. That driller then needs to back up, back onto that hole, drill it back down, pull out. And it's possible that 2, 3, 4, 5 attempts, you still don't have a usable hole. You may need to look at casing the hole. You may need to look at some sort of dewatering methods. There's a number of challenges that will come into play with a soil micropile. That's obviously why driven piles are is the primary choice. Can I get the next slide? Okay, so with that all being said, you know, there's lots of different foundation options. There's a lot of different design considerations that need to go into designing foundations. And, you know, all of those challenges can typically be resolved through a well thought out pre-production load testing program where you're not only testing maybe a couple different foundation types, a couple different variations of the same foundation, but also you're assessing constructability. So, you know, off the hop, one of the biggest advantages of pre-production load testing is you're verifying design assumptions. Any of you that have worked with engineers before know that, you know, in most cases, we collect some information about, you know, maybe one parameter. And this is actually, sorry, specific to geotechnical engineering. A lot of people want to use boreholes as kind of the main means for design. Boreholes are good. I don't want to say they're great. They're good. You know, they give you some information, but they're definitely very, very restricted. And more importantly, you know, you do need to make some crude assumptions to transfer your SPTN value into usable design value for a driven pile, a ground screw, or even a micro pile, which, you know, anytime you need to make a correlation and an assumption, there's going to be some level of conservatism. So this pile testing allows us to make an assumption and then verify it during testing. And by verifying it, we obviously, as the engineer of records, have a lot better grasp on what that actual value is, meaning we could reduce the factor of safety while maintaining the same resistance and, you know, confidence in the design. You know, we're not trying to increase your risk profile here. We're actually de-risking your position by verifying our assumptions. I talked about constructability. You know, a design on a piece of paper with a stamp on it is all fine and dandy, but if it's not constructible, it does nobody any good. So this provides us an opportunity before you go to your site and hire a contractor to put in 3,000, 4,000, or whatever have you number of piles to actually assess the constructability and provide some feedback to the contractor and the developer and the racking company about what are the potential construction risks. So those can be considered and resolved prior to going into production. You develop a better understanding of subsurface consistency. So what I mean by that is the ground is not like steel. Steel, you know, when you order a piece of 33 KSI steel or 55 KSI steel or whatever you've specified, you are as a minimum going to get those properties. The ground, unfortunately, doesn't work like that. The ground could be one condition in one place and 5 feet, 10 feet, 20 feet over, it could be completely different. And because of that change in the subsurface conditions, you may need to be looking at multiple designs. You know, a good foundation design for a site isn't one where you have one design. It's one where you have maybe one primary design and you know what the constructability challenges you're going to have. You know what the subsurface inconsistencies are going to be, and you're ready with a design solution to, as soon as that condition arises, you're going to pull out, you know, remediation option number one, and you're going to put it into action. So that's why having a really good understanding of subsurface consistency is good. And, you know, there's no magic number. Everybody always wants to say, okay, well, you know, I got a 6 megawatt site. How many test bits do I do? Or how many test piles do I do? Well, a lot of it comes down to the consistency. If we go to the site and we dig 15 test bits and we put 25 test piles in and they all give us the exact same results, we're probably good. But if we go do the same thing and half of those results are saying one thing and half of those results are saying another thing, and, you know, we're starting to delineate the site and, you know, okay, we got a pocket of design 1 here, a pocket of design 2 here, but what's going on in this area between those? That's where additional understanding of the subsurface conditions really comes into play and is really going to is going to de-risk your project at the construction level. So like we've talked about, you know, the advantages of pre-production, and you know, I mentioned a little bit about the cost savings. You know, if you do a good rigorous pre-production program and you've got if you've got remediation designs in place and you've got a contractor that is able to not only execute the primary design but also the alternative designs, you're going to have a successful project. And you know, this is obviously very important, but then the other side of this is also, it's very important to have construction oversight. A lot of the projects we've gotten involved with after the fact, where you know, we've been asked to come and look at you know, foundations that maybe didn't go as smoothly as they hoped, a lot of the time it's because there was no site oversight. So you need to have somebody that understands the design, somebody that understands what alternatives you're going to be using in what conditions after the fact during construction. They're with the construction team, they're with the developer, they're with the racking team, whoever, you know, like all projects are kind of put together differently. But ultimately, there needs to be somebody on site that, for lack of better terms, can police the foundation design because of the inconsistency that the ground can throw at you. So that's all for me. I know there's a couple questions, but before we get into the foundation-related questions, I'm going to turn it back over to Vishal, and he's got a couple case studies to talk about.
Yeah, for sure. So yeah, thank you very much for that, Arash. Really appreciate it. Very insightful, and you know, for anyone that's built projects and run into ground issues, I think they can all appreciate how important it is to get a solid foundation design going before you hit the ground. And you said it, you know, we don't only try to give you the right foundation design, but we want to make sure that if you're going to run into issues during construction, you know, we can identify a lot of that in the pre-production testing. So you're going to site with a lot of information up front in terms of how it's gonna roll out, as opposed to, you know, just saying, yeah, I'm gonna go with a grouted pile, I'm gonna show up on site, and you figure out what bones are buried in the ground while you're there. It usually ends up costing you a lot more time and money doing it that way. So highly recommend a very solid pre-production test plan before you start building on these sites. So we only have till 3 o'clock, and I do want to get to a lot of questions. I'm going to race through these two projects, and you know, obviously we're going to send out this presentation afterwards, so you guys can see them and ask us more questions. But I'm going to race through these two projects in the interest of getting to more questions, and you know, while everyone has time. And if anyone has more questions about these projects, we can address that during the question period as well. So we've done a lot of projects in Barbados. I love this picture here of King Gardens because, you know, off to the right you can see some of our flush mount product on that rooftop as well. And this was a 1.2 megawatt ground mount, 150 mile per hour winds. We used 2x10 tables here, 150 tables, and they actually used a grouted pile design here because the ground was pretty hard, and we weren't able to test here. So you know, the grouted pile was a good default in the absence of testing. Had we been able to test here, there may have been a chance that we could have gone a driven pile, but you know, beautiful project nonetheless. You know, very well constructed by one of our customers in Barbados. So. And the second project is a project that we're actually building this year. It's a 6.5 megawatt project in St. Thomas, U.S. Virgin Islands. The wind loads here are extremely high, 180 miles per hour. We're using a mix of 2x10 and 2x5 tables. This is a site that we went out in November and we tested. We're using driven pile on 95% of the site. And, you know, we obviously have remediation options available at our disposal once, you know, if for any reason, you know, the driven pile won't work. You know, there's over 2,500 foundations here, and really exciting project, really exciting customer, and you know, we can't wait to have this one completed. Again, we're not new to the Caribbean. We have been building projects in the Caribbean for the last 8 years. Lots of rooftops as well. So definitely contact us if you have rooftop projects coming. Again, we're quoting a lot more carports for the Caribbean now and ground mount all over. So this gives you a little bit of a map of where we have projects. Barbados, Dominican, St. Thomas, definitely the most when you look at this map. But Puerto Rico, we're starting to see a lot of activity from Puerto Rico right now. We do have projects there, and we expect to be closing on some big ones here in the next weeks. Actually, I know our customer is online here, so I'm giving him a nudge without calling him out by name right now. So last poll question: do you need help designing your projects for the Caribbean or any other location? We'll give you guys a few seconds to answer, and then we'll jump into some of the questions from the chat here. Okay, great. Yeah, for those of you that answered yes, we'll definitely be reaching out to you sooner than later, and we'll end the polling on this one. And yeah, again, really interested in getting into the questions for sure. Before we jump into the questions, if you need to contact us, obviously here's our contact information for Polar as well as PRI Engineering. If you're based in the US or Puerto Rico, reach out to Jonathan. Mr. I, if you're based in the rest of the Caribbean or Canada, definitely reach out to AJ. All the contact information is there. Sales at Polar Racking, in case you want to make it very easy for yourself, and then we'll redirect it to the right person. So again, I really wanted to get to the questions before people start dropping off, because I know everyone's days are really packed. Where do you manufacture? From Richard Fryer. Richard, we manufacture in Canada and overseas in Asia, and we direct ship into the Caribbean. So depending on your product, we will actually and for carports we manufacture in the U.S. as well. So depending on where your project is, we will find the best place to manufacture it for you and get it to you cost effectively and on time. Again, Richard Fryer, carports rated to what wind speed? It's all custom designed to your wind speed. So again, we've quoted on lots of projects recently in Barbados, but we are able to design it to whatever wind it is, and again, it's the structural design. So we make it custom fit to the project area. Francesco asked, do you have east-west racking system? If so, can you speak to that and the wind load requirements? So we actually haven't supplied an east-west system, but we do have a design ready for east-west system. Generally, we find that east-west systems are very low tilt, 5 degrees. And the wind, it actually, there's a lot of benefit to going with the east-west system. If that's the direction you choose to go in from a wind perspective. It's easier to build the south-facing system, by the way, obviously, also. But if you have a project like that, we're happy to look at that and discuss that with you one-on-one for sure. Curtis asked, does your system design consider high salinity environments? So we definitely do. And for all these Caribbean projects, as I mentioned, we use a G210 or higher. We use stainless steel fasteners. Again, that's all to adapt to the environment that these projects are located in. So Richard Fryer, do you have a design for Guam wind speeds? Yeah, we have designed and we've quoted on a project in Guam before. Unfortunately, we did not end up supplying that, but the project that we're doing in US Virgin Islands is at 180 miles per hour. And I believe, again, and you can correct me if I'm wrong, Richard, that Guam is the same. So yeah, we definitely could support you on that project. What's the model that can withstand 175 miles per hour is asked by Francesco. Francesco. It is a PRU, but again, we custom designed this to each site. And so once you contact us, again, depending on the ground conditions and you know, the location, we will, you know, we'll supply you with a design that could withstand that wind rating. Mark asks, which actually is a really great question. I'm really happy you asked this, and it's he says the Caribbean best practice and recognizes wind speeds of, and Carolec recognized wind speeds is 180 miles per hour. Carolec has accepted the RMI documents Solar Under Storm as best practice manual that recommends a 4-post table design. Do you have a ground table for 4-post front and back post? So my answer to that is yes. We do have a front and back leg design, and we do supply it all over. We've supplied in the Caribbean. We've supplied it for projects, you know, in Canada and the US as well. We obviously have read the document. It's really well thought out document, and you know, we appreciate what they are saying. However, Polar, we differ in that in our methodology, in that just saying you should go with a 4-post design front and back leg, you know, regardless of the ground conditions, is something that we don't agree with. So in certain areas, it's going to make more sense to go with a single post design if the ground allows for it. And again, our ultimate objective is to give you the best design for your site. So if the best design we feel is going with a single post driven or a single post grouted, we're not going to push you to go to a front and back leg design if it doesn't make sense. And there's a lot of factors: constructability, again, obviously ground conditions, topology, and the winds, you know, and the wind loads as well, all have to be considered. But we definitely at Polar Racking and PRI don't believe that we should just, you know, ignore the 2-post, you know, or single post design as we call it, and just always go for the front and back leg. That's, you know, that's not what we have the option. We're happy to supply it. It just has to make sense, and the engineering has to tell us that it makes sense, and that's where we stand on that. And I'm really happy that you asked that question. So thank you very much, Mark. Francesco asked, would you use geoballast foundation in the Caribbean? We could. Again, yeah, very site specific, and what's available, the density of the stone, the size of the stone, you know, are all things that we need to consider, how we're going to measure the weight. But for the right site, yeah, we're absolutely open to looking at a geoballast foundation as well. Obviously, we offer a pour in place and a precast ballast options also. So NT asks, what's your opinion on using earth anchors on ground mount projects in the Caribbean? Arash, you want to field that one?
Absolutely. And actually, if you don't mind, I'd like to take on that question and another one because they're kind of related.
Sure.
Which one was it? Okay, anyways, I'll start with the anchors. So one of the challenges with the anchors is going to be kind of really, let's go back to our subsurface conditions. So let's think about the 3 common subsurface conditions we did talk about in the presentation. That's going to be soft rock, hard rock, or soil overburden. Soft rock and hard rock, one of the challenges with the earth anchor is actually penetrating into the rock. You're going to have some of the same similar challenges. And then in terms of the actual engagement of the anchor in the bedrock, it's not able to, you know, really perform like it's intended to. A lot of the earth anchors, how they work is you pound a steel rod, and then there's an anchor at the bottom, and then there's a mechanism at grade that's tensioned, and then that rotates a piece of steel that basically creates an anchor in the ground. So that can only disengage in soil. So you can there's some challenges when you're dealing with bedrock. The concern that comes to the table with soil, obviously installation, getting it in, not a problem. But one of the major issues and concerns in the Caribbean is obviously hurricane season. And when you have a soil site that means it's going to be easily erodible. And if the soil is easily erodible, there's a very good chance you could compromise the soil cover over the actual earth anchor, meaning that, you know, if it becomes uncovered, it's not going to do its job. If it becomes uncovered, it's not engaged in the soil anymore, and it's not going to give you your resistance. We have used earth anchors as a last resort to remediate piles where there's lateral issues. But to be honest with you, in a lot of cases, we only got to that case because a contractor was let to do work unsupervised, and they ended up not following the design, and all other remediations were considered to be too costly. So we used the earth anchor because that was, you know, the best means in the situation we're in. So I wouldn't really say that, you know, earth anchors should be a status quo foundation design, but they definitely could be used as a remediation option, as a very, very, very last resort. And I will say that if your project has gone to the point where you're using that as a last resort, you definitely are going to want to circle back, you know, verify your QC process, verify your contractor's installation process, because there's probably some challenges there that you know that could probably be corrected for future projects, which would eliminate the need for those risky foundation types.
Okay, yeah, great. No, thank you for that. The next question is from Damon Wade. I appreciate the cost will depend on ground conditions, but do you have an average cost per megawatt in the Caribbean that we can use for budgeting? If you've been on my other webinars, you know I do not like to answer this question about cost because it is so vague, and there's so many different factors: ground condition, the size of module you're using, you know, the wind speeds, the orientations, so there's way too much out there. But Damon, if you just send us a quick email about where you are and, you know, what you're considering and what module you're considering, what size project, we're happy to come back to you with a proposal. But, you know, just to give a blanket number out here, I would hate to do it. I could tell you that we're extremely competitive in the market for what, you know, we consider to be a superior product. So, you know, happy to have this discussion with you further. So, Arash, you might have to take this one from Ian. It says, have you worked with any drainage management systems, big tables, and high rainfall rates equal potential ground damage?
Yeah, this is actually, after I put myself back on mute, I found the question. This is the one that I wanted to deal with the earth anchors. So, you know, obviously high rainfall rates, potential ground damage, that's the erosion I was alluding to with earth anchor that, you know, is problematic. One of the obviously biggest deterrents or biggest safety safety nets for reducing your potential for erosion is getting your ground cover. So, you know, it's very important that you make sure that there's, you know, proper growing medium. You know, like all sites are kind of, the final step is to put down, you know, 4 to 6 inches of topsoil or some sort of growing medium. And, you know, often that's skipped. So, you know, it's important to make sure that you're revegetating or allowing the natural vegetation to take over the site. That is by far your best thing to combat erosion. That root structure is a natural system that can take care of that. Other options, you know, you could look at some engineered solutions. You could look at you know, placing stone or other geotextile or ground improving measures that basically would make the ground less erodible. But I'm sure all the developers in the room are saying, well, that's going to add a lot of cost. So, you know, your best bet is to try to maintain your vegetation as much as possible. That is by far your best form of attack against erosion and runoff. Not sure if, hopefully that answered your question, Ian.
Okay, yeah, perfect. So Michael asks, how often do you see the 3-rail support requirements from module manufacturers for high wind loads? do you have a listing of module manufacturers who have modules that can hire wind loads? So the answer to your question is we don't have a full list of everyone that can hire wind loads. Module manufacturers are constantly making our lives difficult by changing their size and their ratings, etc. So it's very hard to keep track of. We are seeing the requirement for 3 rails more and more based on updated module data sheets and install manuals, especially these new split cell modules. So if you do have a project in mind and a module in mind, like we're happy to collaborate with you and figure this out together. So do you use HV as building code requirements for your wind designs in the Caribbean? Do we? So this is a great question, and the structural engineer who is not in the room will need to confirm that and get back to you. HVHC is high velocity hurricane zones. Yeah, as part of the Florida building code. Okay, yeah, so they are using high velocity building code requirements for sure. I apologize, just wasn't familiar with the anagram but yes, we are using that. We provide you with stamp drawings from either Florida engineer or an engineer local to the island that you're working in. So Nathan writes compliments. Thank you, Nathan, for the compliment. Appreciate that. Would you like to hear more? So yeah, next week PRI is actually hosting another webinar about streamlining engineering services and services procurement and construction management. So be sure to tune into that next week if you want to learn more about, again, engineering services and construction management. Again, that's a real missing key here. It's great to have a great foundation design. It's great to have a great product, but having a competent contractor to put it in and someone representing your best interests on site to make sure that what we feel, at least as part of our scope, which is the foundation, which is one of your largest risks, helping to manage that risk by having an engineer on site to review the installation while it's going in. We think it's definitely worth the money, because once the foundations are in the ground, it's impossible for someone to walk the site and tell you if they were done right or not. But if you have a PRI engineer on site while they're going in and testing, testing foundations or a good sample of foundations, exactly like what we're doing in USVI, and like they've done, on many projects in New York and around, Canada as well, it cannot be understated, how valuable that'll be to building a project that is going to last for a very, very long time. So with that, there's no more questions. I'd like to thank Arash, my co-presenter today, for participating in this webinar. I'd like to obviously thank my team, Janet, Natalia, Daryl, for helping us put this together, Mohammed, Mike, Keith, AJ. So thank you very much, team. Thank you very much to everyone that participated. We really, really appreciate this. We will be sending a link out with the recorded version of this presentation, and yeah, look forward to that, and look forward to hearing from all of you, throughout your upcoming projects. We did have some poll results, actually. Janet or Daryl, can you pull up the poll results real quick so we can update everyone? So will you be building a project this year? 50% said yes, 35% next year, 12% said 3 to 5 years from now. So we'll be hearing from 85% of you respondents, at least in the next couple of years. If you're building next year, we should start talking sooner than later. If you're building this year, we should already be talking as we hang up on this webinar. Next question: what are your main challenges in solar project design and construction, sourcing products to meet the loads was the #1 answer. Obviously, we're here to support you with that. And again, we can help you, work with your, inverters not so much, but racking for sure. We can help you, and modules for sure. We can help you work with your module manufacturer to design, racking that will, they can get comfortable with as well. So. The next answer is hiring engineers. Obviously we're supporting with that as well. So what was the last question? Do you need help with your projects coming up? So there are still quite a few of you that said yes for your Caribbean projects and other projects. And happy to hear from you and work with you guys soon. So once again, thank you very much for attending. Really appreciate it. Look forward to hearing from a lot of you and on your upcoming projects and seeing you on one of our next webinars. Take care.